Welcome back. And the next task for this workshop is to perform AutoML model tuning, automated machine learning. And for this feature, we're going to use only the model tuning function, only this capability. We're going to tune a classification task model we will create based on a decision tree algorithm. I'm going to use the same data in our insurance customers table. And again, I'm going to resynchronize my data frame with the data from the database table, dropping the LTV column. This is the numerical column used for regression. We're going to use the classification task in this example. So this column is not required. And we're going to use only the LTV bin classification values we have pre-labeled in our data set. I'm going to split the data between the training and testing data frames using the 80-20% ratios. And I'm going to create my training objects, the matrices X and Y, X with the attributes, Y with the labels for training, and then X test and Y test with the testing object, testing matrices with the labels and labels with the attributes and labels to perform testing and check how the testing has, how the algorithm and the tuning of this model has been achieved on the testing data. I'm going to I'm going to create and start a tuning object, a tuning operation, which I'm calling AT. AT is from AutoML tuning. I'm choosing classification as the mining function. The metric I'm using to compare the best and get the best tuned model is accuracy. And for the model, I'm using decision tree with the X and Y as training objects, training data set I'm using for this model creation. I'm fitting it with the X and Y matrices. It will take maybe some time to create the decision tree machine learning model, and then to create the auto-tuning execution, to create the auto-tuning definition, and also to execute the auto-tuning task. It took about 3 or 4 minutes to create the data model and then tune it automatically with using the automated machine learning auto-tune function. And now we can, from the results, we are going to retrieve the best model and to print it on the screen just to see which one is the best model and how it is tuned, basically, in order to get the most accuracy and the best results for our classification task. We can see here we have the decision tree model classification, and here are the hyperparameters we received from the auto-tuning task that gives us basically the best model for our task, the best tuned model for our exact task based on the data we have. So it is important the algorithm we choose. It is important also to have the data, the proper data, in order to get the results and to get the best machine learning model for that particular data set. So I'm going to show also the parameters, the score and the hyperparameters for this model. So here are the hyperparameters which have been specified or set by the auto-tuning task, and this is the score it achieved. It achieved 86% accuracy, and it has found the values for the hyperparameters for this model in particular. And then we can score it also against the testing data. So the 20% of the data we saved for testing, we can use it now to score this model against the testing data to see what score we get on the testing data. So the tuned model is scoring 92% actually on the testing data. And here we can finish the exercise. This is the mandatory part of the workshop, but the workshop continues on the next. So this is the automated machine learning model tuning. This is the last the last block of code, of Python code in our Jupyter notebook on getting the score on about getting the score on the testing data. But actually this exercise continues in the next part, in part 2. In part 2, we will experience the automated machine learning model tuning, but with user-defined range for the hyperparameters. So in this case, we are not going to let the automated machine learning task to choose the parameters freely, but we are going to provide some limits for the hyperparameter values to be retrieved in the automated model tuning process. And those limits are defined in the search space. So now I'm supposed to go back to my notebooks list here. I'm going to open the part 2 notebook. And if I want to continue to understand even further the automated machine learning tuning process, I'm going to continue with the part 2 notebook in my Jupyter notebooks. I also need to reconnect to my database because each notebook has to be connected to the database at the beginning before we can start running our Python code. And for that, I'm going to retrieve again the operating system values for the host name and for the database service name, and use those values in my connection here in OML, in my OML connection parameters. So let me retrieve the values, and here I have my host name. This is the host name, which has to be specified here, and this is the database service name, which I have to specify here. And this is my connection now. So now I have to reconnect to my database because each notebook has an individual database connection. It's a different session. And I'm going to return the output of the connection here, if it is connected or not, which is in my case is true. And just to verify the connection, I'm going to return the database version, which is 21.3. And now I can continue with the automated machine learning with model tuning task. And I'm going to resync. I need to resync again, resynchronize the data set because this notebook also needs to synchronize the data from the database. Every notebook has a different memory area with different Python objects, and they do not share objects. Every session and every notebook has different Python objects. So I'm going to run again the synchronization for my customers table to be brought into the memory and create the data frame I'm using in my AutoML task. I have to do also the split again for training and testing. And now I can create basically the search space for my hyperparameters values I'm looking to tune. And for this task, instead of a decision tree, I'm going to run a random forest algorithm, machine learning model. And I'm using the classification mining function. The score metric again is accuracy. The results and the auto-tuning task, it is based on a random forest machine learning model using the X and Y training objects, X with the attributes, Y with the labels. And then I'm specifying the parameter space, which I defined here for the values I'm looking to get from the auto-tuning task, just to see if using this search space can affect or improve my model tuning. So, and then I'm going to return the best result and the score of it, the best model tuned and the score it achieves. So again, this is going to take some time. It took about 3 or 4 minutes again to return the score and the hyperparameters for my random forest machine learning model. You can see here, this is the score it achieved, 87%. I think the first one got 86%, and the first decision tree auto-tuned model received an 86% score. This one, which used the ranges in my search space to find the best hyperparameters for my machine learning execution, achieved 87% scoring. So let's say I managed to increase the accuracy of my this machine learning model using a random forest and some ranges I defined in my search space to improve my accuracy with 1%. Again, this can be improved if you spend maybe a few days on a machine learning model, you can improve the accuracy at the maximum score. And now let's see the details of the model I have just tuned for my machine learning task using the AutoML model tuning. And here it is, it's random forest this time. I have classification. Here are all the settings with the values. You can see here the parameters I have tuned using the AutoML is for example, the sampling ratio. This is one of them, and the number of trees, 67, and sampling ratio, and I think also tree impurity metric. This one, the third one here in the list. So here are the hyperparameters I actually tuned using the AutoML model tuning. Okay, and we have all the details about the machine learning model, and now we can score this model again against the testing data, not the training data. We have seen it scores 87% accuracy on the training data. We can now score it against the testing data, against 20% of the data. So on testing, it gets 94% accuracy. because we have the labels. I explained this in the previous videos, and this is how we compare if the model is accurate or not. All the data is pre-labeled already. And we can even use placeholders like values which are defined by the dataset itself, like the number of features or the number of samples. And these placeholders can be used in the search space to define the values in the ranges you are trying to find those hyperparameters in. For example, here I'm using the number of features divided by 2 in the range in my search space. So I can do the same here to tune my random forest model, but in this case, instead of specifying an exact value, I specify a value which is defined by the dataset itself. Let me run this block. And here it is. I defining the ranges using placeholders with some specific values. I achieved a score which is not that good as using the exact values. I have 86%, and the parameter I managed to tune has a value of 10. The one of the parameters of the random forest machine learning model. So this is how it works. Thanks.